If you remember, last time we met, you learned the product rule. And the product rule, you better not, product rule. I want you to say it with me if you can remember it. And if you can't, well, I'm going to keep saying it till you do. Derivative of the first times the second plus the derivative of the second times the first. Do it again. Derivative of the first times the second plus the derivative of the second times the first. Okay. Find the equation of the line tangent to the graph of g of t. Now, you want to write the equation of a tangent line. What do you need to know? Sot and pot. Okay. Slope of the tangent line, point of tangency. What's the x value of the point of tangency? Pi over 6. Let's find the y value of the point of tangency. So g of pi over 6 is this is going to look ugly, but it's okay. Pi squared over 36 times what? Cosine of pi over 6? Okay. Say again? Root 3 over 2. You're going to write pi squared times root 3 over 72. That's your point of tangency. Now we got to find the slope of the tangent line. Now I'm going to write it out a little bit bigger. Do you remember the other day when we were learning this first? I told you circle box. I can't do circle box up here, it's too small. What are the two things we're multiplying together? T squared times cosine t. All right, so g prime of t. Derivative of the first times the second plus the derivative of the second times the first. Remember, put that t squared in front of sine t, otherwise you're going to think it's sine of t times t squared, and you're going to put t cubed. What do we do now? Why do we plug in pi over 6 for t? What are we looking for?
Slope.
We're looking for the slope of the tangent line at that point. So g prime of pi over 6. 2 times pi over 6, what's that, pi over 3? You told me the cosine of pi over 6 was root 3 over 2. So that's going to be what? Pi times root 3 over 6. Is that right? Minus, what's the sine of pi over 6? Half. So what's that? Pi squared over 72. Now listen, you can get a common denominator if you want. That's a safe stop. I would leave it. I would not worry about making a mistake putting those back together. So we're going to write the slope of the tangent line is pi times root 3 over 6 minus pi squared over 72. Now I know you know how to write the equation of the tangent line, but I want to write it with you just to be sure of something, because this thing's kind of ugly. Y minus y1 equals m times x minus x1. Why did I put that m in parentheses?
So you don't. Yes.
That's right, because that that m, that slope has two terms, and we got to remember to multiply the whole thing. Questions? Did you have any trouble with the 6 or 7 questions I gave you to practice on product rule? Were they okay? Or you haven't done them yet? Don't answer. I don't want to know. Oh, snap. While I'm erasing this, I want you to read this and take a look at the graphs, and then we're going to talk about those problems. Below are the graphs of two functions, f of x and g of x. Now notice what p is. P of x is f of x times g of x. R of x is x squared times g of x. Now let's look at the first question there. What is p prime of negative 4? Now look what we're told. We're given this, so don't lose it. We need to find p prime of negative 4. I know what p of x is. How do I find p prime of negative 4? Okay, don't be stupid. How do I find p prime of negative 4? I find the derivative of p, right? Well, now, let's not worry about the negative 4 yet. Let's just find p prime of x, and then we'll evaluate that at negative 4. But if you'll notice, p of x is f of x times g of x. I'm sorry, I didn't mean to say stupid. I shouldn't have said that. My apologies. P is a product because it's f times g. So let's write down how to find p prime of x. What's p prime of x? Circle box. First, second. So p prime of x is the derivative of the first, which is, not in yellow. What's the derivative of the first? F prime of x times the second, g of x, plus the derivative of the second, g prime of x times the first, f of x. Now we're going to evaluate that at negative 4. So p prime at negative 4. Now I'm just going to write all of this out. I'm just going to substitute negative 4 in there. And we've got to go find each one of those values. Please notice that one of those values is given right here. We know what g prime of negative 4 is. So what's f prime of negative 4? What's f prime of negative 4? That's the graph of f. Why negative 1? That's the slope, right? So negative 1. So that's negative 1 times, what's g of negative 4? I cannot see on here at all. You're just going to have to tell me. What's g of negative 4? 6 plus g prime of negative 4. That's what was given here. Times f of negative 4. Look on your graph. Negative 1. What's that give you? Negative 8. So p prime of negative 4 is negative 8. Questions? Okay. Go below. Find the equation of the line tangent to p of x when x is negative 4. I sound like a broken record, and I mean to. If I'm writing the equation of a tangent line, what do I need to know? Sot and pot. What's the slope of the tangent line at x equal negative 4 on p of x? That's what we just found. Your point of tangency. What's the x value of your point of tangency? Now we got to go back up to the equation of p of x and evaluate that at negative 4. This says p of negative 4 is f of negative 4 times g of negative 4. So you got to help me. I can't see the g. What's f of negative 4? F of negative 4? F of negative 4 is negative 1, and you said g of negative 4 was negative 6? 6. Okay, so -6. I'm going to leave it to you to write the equation of that tangent line. You all can do that. Please tell me you're writing down what y plus 6 equals -8 times x plus 4. Okay. Let's go back up here to this r prime. R prime of -2 is 20. What's the value of g prime of -2? We are given an equation for r. X squared times g of x. X squared times g of x. How do we find r prime? What rule are we going to use? What rule are we going to use to find the derivative? Product rule, yep. You only know two. You know the power rule and the product rule. That's all you know right now. R prime of x. Just talk it out in your head. Derivative of the first times the second plus the derivative of the second times the first. R prime of -2 is 2 times -2 times g of -2 plus g prime of -2 times -2 squared. G of -2, I can't see, help me. What's g of -2? -3. So this is -4 times -3 plus, I wrote something, that's g prime of -2. That's what I'm looking for, isn't it? That's what I'm looking for. 4 times g prime of -2. But I can fill this spot. What's r prime of -2? 20. There you go. That's algebra. So algebra it, and figure out what g prime of -2 is. Now, I forgot to write that, or I forgot to record right there. So right there, and then I got to stop because I got to go answer a question. What do you get? 1 minus -2 over 1? 3? Huh? Because if I'm trying to find the slope, I want to find the slope of that line. To find the slope of the line, I do the difference of the y's, the change in y over the change in x. We're just going back to algebra 1. Let's look at q of x here. Now, there are a couple things I'm going to show you on this q of x question. What's the value of q prime of 4? What do we do? What do we do? Take the derivative of what? Of q of x. Take the derivative of q of x. Now, listen. Well, we'll get at it this way. What's the derivative of 2f of x? What do you think? That's what Carson thinks it might be. Carson's right. Were you worried? Were you worried? A little bit, yeah, a little bit. Now, look. If f of x is 3x to the 4th power, you can tell me what the derivative is. 12x cubed. What if I did 3 times the derivative of x to the 4th? Will that give me the same answer? What's the derivative of x to the fourth? 4x cubed. Is that 12x cubed? Bet your boots it is. If you've got this coefficient out here, you can just not worry about it. Find the derivative of that and then just multiply back together. Now, there's something else I want to show you. But wait, Stennett, that's a product. Why don't we use the product rule? Because aren't we multiplying two things together? Ah, yes. Ah, yes. What are we multiplying together? 3 and x to the fourth. Oh, so that should be a box. Circle box. So let's do it. F prime of x. What's the derivative of the first? What's the derivative of 3? You're killing me. It's a constant, and the derivative of a constant is 0. What's 0? This is 0 times x to the fourth. So the derivative of the first times the second plus the derivative of the second times the first. What's this? That's 0. So this is 12x cubed. Oh my gosh. Oh my gosh. The product rule, I didn't teach you the product rule. I just taught you to multiply the derivative of that by 3. But if you want to use the product rule, it works, but there's no point in it. Okay. So when you have a coefficient multiplied by some function, it's just the coefficient times the derivative of the function. All right, finish this one. What's the derivative of the rest of this thing? That's right, minus 4g prime of x. That's it. So what is q prime of 4? Well, it's 2 times f prime of 4 minus 4 times g prime of 4. And you go pull those off the table. What's that, 16? Or did I screw it up? 16? Let's go talk about this p of x over here. How many terms are we multiplying together? 3. Now, believe it or not, you can do the product rule with 3 terms. And the way it goes is this. The derivative of the first one times the other 2, plus the derivative of the second one times the other 2, plus the derivative of the third one times the other 2. But I don't want to do that. Because what is my first term in here? It's just a coefficient. So what we're going to do is we're going to do what we thought about before, and we're going to write p of x equals negative 2 times f of x times g of x. We're just going to take the derivative of f times g and multiply it by negative 2. Okay? Let's go. Let's do it. You do it, I'll do it, and I'll try to do it with my mouth shut. F prime of 3 is negative 4. G of wish I could remember more than one of these at a time. Frick. What's the matter? Did you? Oh, that'll do it. Just a happy little accident. Okay. All I want us to do is take the derivative of v. We're not going to worry about writing the equation of the tangent line. Slacker.
I messed up at the beginning.
Oh, is that? And then you gave up. What are we multiplying together here on v? What are we multiplying? X cubed and f of x. So circle box, x cubed and f of x. All we're going to do is get the derivative. All right, let's get it. V prime of x equals. Talk to me. Derivative of the first. Tell me what to write down. Times. Perfect. Plus f prime of x times x cubed. Yeah. Don't take the time to finish that problem. I just want to make sure you can take the derivative. I know you can do the rest of it. Let's get this last problem right here. K of x is that. All right. What's the value of k prime of 3? Let's just get the derivative. If this is a product rule, then we ought to be multiplying a couple things together. What are we multiplying together? Those two things in the parentheses. So 2f of x plus 3 is one of them. And then 3 minus g of x is the other one. K prime of x. Yep. Derivative of the first, Ava said, was 2f prime of x times the second. Plus the derivative of the second. What's the derivative of the second? Negative g prime of x. Good. Erase that plus, and we're just going to put minus g prime of x times the first.
Wait, I think I know, but just clarify.
Yep. Because the derivative of g of x is g prime of x. Yeah, 3 is a constant. Yeah, 3 is a constant. And then that's a minus 1 times g of x. Yep, okay. Now, I want to go through the proof of, or I want to derive the product rule with you. I want you to see where it comes from, that it's not just magic. You do not have to write this down. Do you hear me? I just want you to think through it with me. I will not ask you to do this derivation by yourselves. I just need you to understand that it's a real thing and that mathematicians figured it out once, and don't ask me how they're smarter than I am. All right. I'm going to let h of x equal f of x times g of x. Now, folks, the way you prove anything about a derivative is to use the definition of a derivative, which is the limit process. Oh, f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. That's what we have to do here. Oh my gosh. So, h prime of x. If I lose you, stop me, okay? And if you stop me real soon, I'm going to maybe cry a little bit. Now, this h is not this h, okay? Remember, I evaluate the function at x plus h minus evaluate the function at x. Remember, because it goes like f of x plus h minus f of x. So I have to evaluate that function at x plus h minus the original function. To evaluate that function at x plus h means everywhere I see an x, I'm going to put an x plus h minus the original function. It gets really bad before it gets better. What I have to do, well, let me just show you. One technique that you can use when you are proving things is you can add 0. Now, we know we can add 0 anytime because adding 0 may change the way something looks, but it's not going to change the value, right? So I'm going to add 0, and you're like, what are you talking about? H prime of x equals the limit as h approaches 0 f of x plus h, g of x plus h. I got to think how I want to add my 0. I got to remember. Minus f of x. I think this is right. If it's not, I'll go back and fix it. Now my problem is I run off the board. Yeah, people who are watching on the, yeah, you can skip this part because this is not part of your homework. Now, yes, this will work. So I got this whole big fraction. Now what I'm going to do, how many terms do I have in the numerator? I got 4. I'm going to break this into 2 fractions. I'm going to take 2 of those terms and put it over h, plus the other 2 terms and put it over h. Okay? That's what I'm going to do. So, I'm going to write, golly, you know what? I'm going to stop recording because I'm going to have to go to a whiteboard, so don't worry about it. So we are segueing right into finding the derivative of quotient. Now I want you to take a look at this one. Yes, this is a quotient, but it doesn't have to be. You guys know how to solve that one. How would you rewrite it the way I taught you? Do it. What's it going to look like? What would you get? Help me out. 2x minus 3. Good. Ladies and gentlemen, when you have a problem like this, rewrite the darn thing as a polynomial type function and take the derivative that way. Don't use any other rule. Do you understand me? What's the derivative? Oh, whoops, I just wrote f prime. That's not f prime, is it? That's just a rewrite. What's the derivative?
Minus 4x to negative 4x. Oh, or that.
Oh, or that.
Yeah, good. Yeah, same answer. Same answer. if you want to do this as the quotient rule, which you're getting ready to learn, you're going to get the same answer, but it's going to take you a heck of a lot longer. And this is way easier. Do this. You are going to, golly, so help me, you're going to forget this, and then you're going to go, oh, don't forget this. Just as Leibniz was the first to publish a proof of the product rule for differentiation, Isaac Newton was the first to publish a proof of the quotient rule of differentiation using the limit definition of the derivative. We are not going to go through this limit process, okay? But we are going to write the rule together. All right. Oh, yeah. Let h of x equal f of x over g of x. Then h prime of x equals, all right, don't freak out on me here, f prime of x times g of x minus g prime of x times f of x over g of x quantity squared. Now, Leah's sitting back here with a little grin on her face because she knows what's coming next. She got this yesterday. Have you got it written down? Cancellation? No. Dang it. Top, bottom. Okay? Derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. That's how I want you to remember it.
Oh.
All right, let's do it again. Derivative at the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Okay. All right. If you can, that'll be fine. Hi and ho. Hi and ho.
Hi ho.
Now when I say D, there are a bunch of crazy people in here. When I say D, I mean derivative. Okay? Ready? Ho d high minus high d ho over ho ho. No. Ho d high minus high d ho over ho ho. Okay. Look. Ho d high minus high d ho over ho ho.
I'm gonna get a flip.
All right.
Hi ho.
But the way I remember it is the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. All right. Okay, don't listen to anything that comes off this front row right here because they will mess you up. You three.
Hi ho.
Hang on a minute. I'm not going to go back through this one with you. That's a waste of time. I do not want you to do that one with the quotient rule. Just believe me when I tell you if you did it, you'd get the same answer as we got up there. Thank you. Okay, go to this last problem right here. Because this problem right here you couldn't do as a polynomial. All right. We are not going to write the equations of tangent lines. We don't have time. We're going to take derivatives. You guys can write equations of tangent lines. Okay, sock pot. There you go. Okay. G of x equals 2x minus 1 over x plus 3. What's the top? What's the top? Yeah, I know the top is high. No, the top is 2x minus 1. What's the bottom? X plus 3. Okay. You already taken the derivative. Okay. All right, so here we shut up. He's up here going salt and pot. All right, derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. And that's how you use the quotient rule. Now let's clean it up a little bit. If you are in a free response problem, this is a safe stop. If you are in multiple choice, this will not be one of the multiple choice options. So let's just clean it up a little bit. What are you going to have? 2x plus 6. Keep going. What do we got? What? What's the top? 7. 7. And if you FOIL this out, I would count off points because you were a knothead. Don't FOIL that out. Just leave it alone. We'll FOIL it out. In your head. What is it? You don't. There you go. Now, my goal for today is to get these 4 done. Guess what? You know what the derivative of sine x is. What's the derivative of sine x? Cosine x. What's the derivative of cosine x? Now, we're going to find the derivative of tangent, cotangent, secant, and cosecant. Aha. What? Shut up. Once we find them, you're going to learn them. So you don't have to go through this process again. You've got to know where it comes from. So we're going to do the product rule. We are not going to do the limit process. We're just going to do the quotient rule. You say, well, that's not a fraction, Stennett. I can make it one. What is it as a fraction? Top is sine theta. The bottom is cosine theta. Here we go. F prime of theta. Derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. But remember, when you square cosine theta, make sure you put the square in the right place. I heard, ooh. No. What's it going to end up being? The numerator is cosine squared theta plus sine squared theta. 1. 1. 1. No way. 1. Yeah, it's the kahuna. Yeah. This is 1 over cosine squared theta. Which is secant squared theta. Ladies and gentlemen, the derivative of tangent theta is secant squared theta.
Wow.
Know it.
Never.
Derivative of tangent theta is secant squared theta.
I'm with you.
This is a conspiracy. Well, not on purpose. Cotangent. Now, before we start cotangent, derivative of sine theta is cosine theta. Derivative of cosine theta is minus sine theta. The derivative of tangent theta is secant squared theta. What do you think the derivative of cotangent theta might be?
It's 1.
Write it as a fraction. What's cotangent? Cosine over sine. And here we go. Derivative, shut up, it's not undefined. Derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Oh. Negative what? Huh? What is it? Negative 1 over sine squared theta. Aha. Negative cosecant squared theta. I don't know, it does that now and then in that area of the board. Can I scroll up? Yep. Where'd I lose you? Here we go. Secant theta. Okay, think about what you know so far. Can you make an educated guess about what the derivative of secant theta might be?
Negative 10.
Okay, let's see. Can we write secant as a fraction? 1 over cosine theta. They have much faith in you, dear. Derivative of the top. 0 times the bottom minus the derivative of the bottom times the top over the bottom squared. What is this? Sine theta over cosine squared theta. Now, I'm going to break that up. Well, that won't get me anywhere. It's a good idea, but it won't get me anywhere. Let me show you.
Quick announcement before the bell rings. The cross-country meet that was scheduled in Greenwood today had conference.
Fourth time.
Thank you.
Now, I want you to look here. Are you okay with how I broke that up? This is times. All right. Well, what's sine theta over cosine theta? Tangent theta times secant theta. The derivative of secant theta is secant theta tangent theta. Well, we could, but you'd be wrong. So, yes, yes. Learn them. Learn them. Now, listen. I'm gonna give you homework for this, but you're only gonna do a little